To the two of you who are not here, which was who, Nathan and Avery. I forgot to start the recording as soon as we started. We are on the second to the last page of the notes. Okay. Now, how do I get the H by itself? So I get H equals B sine C. Now, let's look at the second question. Using angle B, find an expression for H in terms of C. So I got to go to the other one because I need to have angle B in it. So I want to find an expression for H in terms of C. So I want to use those three pieces in my trig ratio. Indeed, it's the same thing. The sine of angle B is what over what? H over C. How do I solve for H? Multiply by C. Good. So H equals C sine B. Oh my goodness. If H is equal to this and H is equal to this, I can set them equal to each other. So I'm going to write B sine C equals C sine B. All right. I am going to divide both sides of that equation by little b times little c. I want you to do this. That's a legal mathematical maneuver. I can, as long as I do the same thing to both sides, I can do it, as long as I'm not dividing by 0. How do I know I'm not dividing by 0? Because I cannot have a side length of 0. Good, good. Now, so the question is, what do I have left? Well, the b's cancel there, and the c's cancel there. So I've got the sine of c over little c equals the sine of b over little b. Ladies and gentlemen, that is the law of sines. That's the law of sines. Now, the law of sines really has 3 fractions in it, not just 2. We could go through where it all comes from, but look at this and tell me what fraction you think is missing. Sine of a over little a. So, I'm going to do it this way. I'm going to write it this way to try to at least get you thinking with Greek letters. Remember, alpha is the same as angle A, beta is the same as angle B, gamma is the same as angle C. We good there? So I can write sine of alpha over A equals sine of beta over B equals sine of gamma over C. I like writing it that way because instead of saying sine A over A, it makes it sound like the A's are the same thing when they're not. One's a side and one's an angle. This equation is really powerful. You will be able to use that on lots and lots of different kinds of triangles. Now, let's do one. In triangle ABC, we're told 3 pieces. Solve the triangle, finding all the missing measurements. Do you notice that one of the angles is obtuse? Please do not draw a triangle that looks like this and say that's 130 degrees. Okay? Draw a triangle where you've got an angle that's obtuse. You can put an asterisk and say not drawn to scale. I'm going to do it like this. I'm going to name these alpha, beta, gamma. Please do not be stressed about Greek letters. It's not an issue. It isn't. Now, if you want to use big A, big B, big C, that's fine. Same thing. All right, B is 15. C is 11. You'll notice the law of signs has 3 fractions in it. If I'm going to write an equation, I can only use 2 of those fractions. And I have to look at the triangle I'm given to decide which of those 2 fractions do I need to use. Why do I need to use sine of beta over b? Because I know both parts. Are you doing this in college algebra? No. Well done then. All right. Now, that's right. You can only have one missing piece. So do you notice that I know angle beta and side B? So I'm going to use this one. So let's write that down. Sine of beta, which is 130 degrees, over side B. Now, which other fraction should I use where I only am missing one piece? I got to use the C part, so I'm going to do sine of gamma over C. How do you solve this equation? Cross multiply. So I've got 11 sine 130 degrees. Please put degree symbols where they are needed, but you do not have to enter them in your calculator. Equals 15 sine gamma. How do I solve? What do I do? Divide by 15? Yep. And so I'm going to have sine of gamma equals 11 sine 130 over 15. Same thing. I would if I took this proportion and I multiplied both sides by 11, it's the same thing. Yep, no problem. How do I solve this?
You put the sine of 130.
Right. I mean, this right here, this is just a number, isn't it?
Yeah.
So I've got sine gamma equals some number. How do I get gamma by itself? How do I undo sine? Sine inverse. So I'm gonna sine inverse both sides. (34.178 degrees). I want you to store that because angle gamma means angle C. Let's store that in C.
Whoa.
Now I know angle gamma. How do I find angle alpha? How do I find angle alpha? Easy. Yeah. 180 minus 130 minus gamma will give me alpha. So we did 180 minus 130 minus gamma. So we got alpha is 15.822 degrees. I'm going to tell you to store everything. That way, if you need it, you've got it. And if you don't need it, well, you lost yourself 2 keystrokes. So let's store that in A. If you stored something in A yesterday, then when you store this, it'll just overwrite that. So this is stored in A. So now I know this. There's one piece I don't know. What is it? I don't know side A. Why can't I use Pythagorean theorem? Not a right triangle. Okay, so, oh, I know law of sines. I can do any of them, can't I? Because I've got everything stored. So I can do any of them. Now, I'm going to use sine beta over b because those are just nice, easy numbers, right? So, what fractions, what equation will I need to use? I'll do sine beta over b. And I need to find side A. So what am I going to do? Sine of, I need to find,
Sine of alpha.
yeah, so sine of alpha over A. Now remember, you have this stored in A. So let's solve it. Cross multiply. A sine 130 equals 15 sine alpha. But again, that's not a variable right now. We know that number. We have it stored. What do we do?
15.
Yeah, I need to get this A by itself. So I'm going to divide by sine 130. Go to your calculator, but remember you have that stored in A. What are you getting? 3 decimal places. 5.339. We have found all the angles and all the sides that we did not know. I'm sorry? No, we're done. We found everything. So we're finished. We don't need to save anymore. Now, I want you to take a look here. You need to make sure that you know what we're getting ready to say right here. In order to apply the law of sines, what combination of information do you have to know? In order to do law of sines, you have to know an angle and its opposite side. If you don't know an angle and its opposite side, you cannot do law of sines. So, what combination of information must be known? You must know an angle and its opposite side, and one other piece, either one other side or one other angle. Go back to geometry for a minute. Do you remember when you drew all those triangles and you did stuff like side, 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 angle, side? That would be like side, angle, side, like that. Yeah, that's dirty. We don't teach you dirty things. We don't do side, side, angle at this point. I will teach you later how to do side, side, angle, okay? Angle, angle, side. There was one. Okay. And I believe there was angle, side, angle.
Yes.
Is that right?
I think so.
Now, ASA, yeah. Can you use law of sines on any of those? Cannot use it on side, side, side for sure. I can use it on angle, angle, side? Sure can. I can use it on angle, angle, side because I know an angle and its opposite side and one other piece.
Well, if it's in a different order, you can use the side angle side, can't you?
You can't can't be in a different order, then it's not side angle side.
Oh, okay.
But there is one other that I can use law of sines on. Why?
Because you know the other angle.
Because I know the other angle. Yep. Because I can calculate the other angle easy, and then I have an angle in its opposite side. So, law. Don't you start doing this to me today. Ah! Okay. All right, I think we're back. I can use law of sines here and here. I cannot use law of sines on those top two because I don't know an angle on its opposite side. And I don't have a way to find it. Ladies and gentlemen, welcome to the law of cosines. Now, if the law of sines cannot be applied, we must use the law of cosines. You're going to write 3 lines. Now, horizontally, 3 lines. Now, I could show you, 3 rows. I could show you, if you want me to next week, I will. I'll show you where this comes from. But right now, I'm just going to show you what it is and how to use it. The first one, and you're going to have to memorize it. You do not get these on a cheat sheet. A squared equals b squared plus c squared minus 2bc cosine alpha. A squared equals b squared plus c squared minus 2bc cosine alpha. The ACT, if they ask you to use law of cosines, they will give you the formula. B squared equals a squared plus c squared minus 2ac cosine beta. Can you figure out how to write down the last one?
Yes.
C squared equals a squared plus b squared minus 2ab cosine gamma. My smartboard's having seizures. Now, ladies and gentlemen, the Pythagorean theorem is a special application of this one. Do you see the Pythagorean theorem hidden in there?
Yes.
C squared equals a squared plus b squared. We will come back later, and I will explain that to you, why it is. You're not ready yet to know. But the Pythagorean theorem is a special application of law of cosines. All right.
Equals the other portion equals 0.
Yes, correct. Here's what Rebecca said. Rebecca said, is it because there's some way that... there is a reason that that piece is 0 in a right triangle. Okay. Now, before this thing freaks out on me anymore, let's go we got 2 problems to do, all right? Shoot, we're doing good. All right. Now, let's keep it up. So we got 2 problems to do. We're going to solve the triangle, which means find all the missing sides and the missing angles. What setup are we given in that first problem? Side, side, side. So we're going to draw a side, side, side. I'm going to go angle alpha, angle beta, and angle gamma. There's side A, side B, side C. And then I'm just going to put stuff in that I know. A is 6, B is 4, and C is 9. I know all of the sides. I need to find the angles. So we're just going to pick one of these. It doesn't matter which one we start with. Why don't we start with the top one, the one in the purple? So let's write down a squared. Write that one down. A squared equals b squared plus c squared minus 2bc cosine alpha. Alpha, not gamma. Now let's plug in what we know. We know that A is 36, so a squared is 36. We know that b is 4, so b squared is 16. C is 9, so c squared is 81. Minus 2 times 4 times 9 times cosine of alpha. Are you all right so far? All right, let's keep going. 36 equals, I believe that's 97 minus 72 cosine alpha. Please do not go past this. I'm going to make a mistake that some of you are going to make. And the reason I'm going to make it is to try to keep you from making it. Tell me what my mistake is. 36, would you shut up? Give me a minute. 25 cosine alpha. Those are not like terms. I cannot combine those because they are not like terms. Please don't do that. Somebody's going to do that. So, did you really? How do we solve that? Subtract 97 and then divide by negative 72. 36 minus 97 is what?
61.
All right, so I end up with negative 61 divided by negative 72, right? Negative divided by a negative is a positive. You can combine two steps like that. You guys are smart enough that that's not an issue. How do I get alpha? Cosine inverse. We're going to cosine inverse both sides. I don't really have room in there. Okay. All right, cosine inverse, do it. Approximately?
32.08.
What? Degrees. Store that in A. I know alpha, so I know that angle. Now, and you have to be careful because you can't do that. And I am glad you mentioned it. Ladies and gentlemen, once you start with law of cosines, you have to stay with law of cosines. You cannot interchange them. Why? Because sometimes it works and sometimes it doesn't. You don't know enough trig yet to understand why. But I just need you to trust me right now. When you start with law of cosines, you stay with law of cosines. I know. Woohoo! Okay. But the nice thing is, we only have to do law of cosines one more time, because then we'll know two angles and we can do 180 minus and find the other one. All right? Gus is having a hard day. Poor Gus. Okay, let's go find angle beta. So if we're going to find angle beta,
I say yeah.
well, fine, go find gamma then. I'm going to find beta.
I'll say
B squared equals a squared plus c squared minus 2ac cosine beta. Plug in what you know. You know b is 4, so b squared is 16. A is 6, so a squared is 36. C is 9, so 9 squared is 81. A is 6, C is 9, cosine beta. Now do cosine inverse of both sides. You getting 20? All right. Now, listen, you do not have to show any work on gamma. I would expect you to go to your calculator. I would expect you to store that and do 180 minus A minus B and pop out your gamma. We good? Is that a big angle? 127 something? That's the one piece you don't have to show any work because, duh, I know you can do 180 minus, okay? Okay. Now, we're not going to do all of the second question. We're just going to do part of it. Please notice that this is a little different setup because you're given an angle. So let's just start it. You did it again, dadgummit. Give me 5 minutes, that's all I need. I'm talking to the smartboard. Where's, come on. All I need is 5 minutes. Just give me 5 minutes. Right there. Give me 5 minutes right there. Okay. Alpha, beta, gamma, A, B, C. A is 12, C is 7, B is 65 degrees. On the first question we did on this page, we had a side, side, side. What do we have now? Side angle, side. Good. Now, so I've got 2 angles to find and 1 side. There's only one of those options that I can use.
The last one.
Why?
Because you have 2 sides and 1 angle. No, the second one.
Why the second one?
Because you know side C and A, and you know angle beta.
I know angle beta.
Beta, yeah.
I know angle beta, so I'm going to use the one that's got beta in it. So I'm going to use B squared equals A squared plus C squared minus 2AC cosine beta. Plug in what you know. B squared equals A squared plus C squared minus 2AC cosine of 65 degrees. Got it written down? Folks, you can go right to your calculator and type that in just like that is. Now here, listen, I had somebody yesterday do this. They typed in all of this, hit enter, and then multiplied that answer by cosine of 65 degrees. Why did that give them the wrong answer? That's right, this part's not being multiplied by cosine. So we're just going to type that in as is. Remember to square root your answer because you're going to get a b squared. Oh, don't want to use yellow. B is approximately 11.045. Is that a degree measure? No, because it's a length. Store that. I would store it in B. Now remember, whatever was in there before is just going to be overwritten by this new value. Now let's go back. I know what that is. Don't go to law of sines, you can't do that. However, now I need to find these 2 angles right here, correct? Now, we're not going to do it. We're just going to talk through it. Let's just say I want to find angle alpha. Which of these three am I going to use?
First one.
The first one. And keep in mind, you've already got side B stored. So you would use your stored value. Then once you find this one, then
180.
that's right. Store that, do 180 minus, and you'll find angle gamma. Do we need to work through that, or did you understand what you would do? I figured that would be okay. Ladies and gentlemen, law of sines and law of cosines are extremely powerful in trig. Know them. All right? Know them. Good. They don't get harder than this, so. All right.